Hello mathematicians and welcome to 99 Problems Math. I asked ChatGPT to tell me the number one problem that every student in geometry needs to know, and this is what they gave me. We're given 3 points that form a triangle ABC. We need to classify the triangle and determine if it's a right triangle, and we have to show proof. We can't just say that it looks like a right triangle. And then the second part, part B, we have to calculate the perimeter and the area. So we're going to have to take this one step at a time. Why don't we just try plotting the points on the coordinate plane first and see what happens. So A is at -2, 1. There's point A. Point B is at 6, 1. And point C is at 2, 4. So here's our triangle ABC. All right, first up, we need to classify by its side lengths. And if we're solving for the length of a side, we are going to need the distance formula. So the distance between 2 points can be found by taking the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. Let's start with finding the length of side AB. That is our flat side here, so we don't even need the distance formula for that. We can just count how many units it is on the coordinate plane. So from A to B, that's going to be 1, 2, 3, 4, 5, 6, 7, 8 units on the coordinate plane. To find AC, we will need to plug into the distance formula. All right, so x2, we're going to call the x-coordinate of C, so that's going to be 2, minus the x-coordinate of A, -2, squared, plus y2, which we're going to call the y-coordinate of C, minus y1, which is the y-coordinate of A. When we simplify what we have here, so I see 2 minus -2, and if I remember, when I subtract a negative, that's like adding a positive. So really what we have there is 2 plus 2, which is 4, plus, other parentheses, 4 minus 1 is 3. So I see now, inside my square root, I have 4 squared, which is 16, plus 3 squared, which is 9. 16 plus 9 is 25, and 25 happens to be a perfect square, and I know that the square root of 25 is 5. All right, so automatically I see that I have one side length of 8 and one side length of 5. So that tells me that this triangle is not equilateral, because an equilateral triangle would need to have 3 congruent sides. Now we have to check side CB. We're going to need to plug into the distance formula. All right, and this time x2 is going to be the x value of coordinate B, which is going to be 6, minus the x value of C, which is 2, squared, plus the y-coordinate of C, or sorry, the y-coordinate of B, which is 1, minus the y-coordinate of C, 4. we have 6 minus 2, which is 4 squared, plus 1 minus 4, negative 3 squared. 4 squared is 16, plus, and we need to remember that anytime we square negative, it becomes a positive number. So negative 3 squared is positive 9. And just like with the previous side, 16 plus 9 is 25, and that gives me a distance of 5. So I know that I have two side lengths that are each 5 units. That's going to make this an isosceles triangle, two congruent sides. Now, there's still a second part of part A. Determine if it is a right triangle. Now, there are a few different ways that we could determine if it's a right triangle. The way that I think is going to be the easiest for us is to plug into the Pythagorean Theorem. A squared plus b squared equals c squared. And when we plug in our three side lengths, if we get the same number on both sides of the equation, that means we have a right triangle. If we get different numbers on each side, we do not have a right triangle. So a and b can be interchanged, but the one number that matters is c, our hypotenuse. That has to be the biggest side, which was 8. So a and b are going to be our two other sides, which are going to be 5 squared plus 5 squared. Well, 5 squared is going to give us 25 plus 25, and 8 squared is going to give us 64. 25 plus 25 is 50, and 50 is not equal to 64. So because we did not get the same value on both sides of that equation, this is not a right triangle. So what we know so far is that it's an isosceles triangle and it is not a right triangle. Now, part B, calculate the exact perimeter and the exact area of triangle ABC. Let's think about how we calculate those things. Well, how do we find the perimeter of something? The perimeter is what you get when you add up all the sides. Well, in part A, we already found our three side lengths. We said that the three side lengths of the triangle are 5, 5, and 8. And if I add those three numbers together, I'm going to get a perimeter of 18. So we know that the perimeter of this triangle is 18. Now we need to know the area. Area of a triangle is 1/2 base times height. Now the base is going to be side AB. That's kind of our flat horizontal side. So the length of the base was 8. Now the height of the triangle is not one of those two other sides that we calculated before. The height of the triangle is perpendicular to the base. It means it forms a 90-degree angle with the base. So the height is actually going to be from point C down to the base so that it forms a right angle. And since that's a vertical line, we can just count the units. 1, 2, 3. The height is 3. One half of 8 is 4. 4 times 3 is 12. So the area of this triangle is 12 units squared. So according to AI, this is the most important question that a student in geometry should know how to do. And now you know how to do it. This has been 99 Problems Math, and now math isn't one of them.